So hi everyone. Let's start with the solution of this question. I believe that this is a very good and cute question. If you see KROTOV, the solution given is very, very lengthy and very complicated mathematics. Like you see that it is supposed to be P1, V1, and then we are supposed to, calculate the area and get in same terms and then compare. So that is very lengthy. But I'll be sharing here the method of calculus actually, which will help us derive the answer in just a few lines. Few lines. Okay. So, firstly, what we need to understand the temperature here is T1. Okay. And, these 2 points are having the same temperature. So, in process 1 to 3 and in process 1 to 2, the temperature difference delta T is same. Okay. So, if delta T is same and it is an ideal gas, okay, by default we suppose them to be ideal gas until and unless it is not mentioned that it is a real gas. So if delta T is same, that means delta U, that is change in internal energy, is also same. Okay. So now we have to compare in which in which more amount of heat is supplied. So that means clearly we can see that Q directly proportional to the work done. ठीक है. अभी देखो ये कोई ऐसा आई मीन सिमेट्रिक या ऐसा कोई ग्राफ नहीं, ये इन जनरल ग्राफ बना हुआ. ठीक है, दिस इज अ ग्राफ इन जनरल. सो यू नो इवन इफ वी फॉर प्रोसेस 1 to 3 अगर थोड़ा सा चेंजेस करें, इफ वी चेंज इट स्लाइटली, लाइक इफ वी कैन डू इट लाइक दिस. ओके, इसको 1 से 3 वाले को अगर मैं ऐसे बना दूं, देखो इसको थोड़ा सा नीचे गिरा दूं. ठीक है, 1 से 3 वाले को, अरे यार ये चल क्यों नहीं रहा है, इसको ऐसे नीचे गिरा दो तो कोई ज्यादा फर्क नहीं पड़ेगा. और ये 1 to 2 को अगर मैं थोड़ा सा ऊपर कर दूं, कोई फर्क नहीं पड़ेगा. यहाँ पे मैटर करने वाला चीज क्या है ना, कि ये जो 1 से 2 वाला है, दैट इज मोर ऑन द आइसोकोरिक साइड. ठीक है, I do understand that these two lines are not perpendicular, but since this is a question in general, so we can we can change it, right? And for process 1 to 3, we can suppose this to be isobaric. All right. And in which case the work done is more. You will have to say me this. Isochoric, actually the work is tending towards 0. And for isobaric, that will yield a constant finite value. Okay. By finite we mean कि 0 नहीं आएगा, कुछ एक अच्छी खासी क्वांटिटी आएगी अपने पास. So for process 1 to 3, okay, for process 1 to 3, for we are getting a finite value of work. और अगर finite value of work है तो यानी कि process 1 to 3 में heat जो है वो ज़्यादा absorb होगा. absorb या सप्लाई करोगे तो absorb ही होगा बेसिकली. ठीक है, ये हो गया आंसर. ये इसको मैंने इन जनरल दे दिया. ठीक है, अब अगर लाइक इसी को अगर मैं थोड़े से कैलकुलस के फॉर्म में देखूं तो आइए देखते हैं. लेट्स सी इट फर्स्ट. ओके, मान लो ये एक आइसोथर्म है टी टेम्परेचर का, और यहां से जस्ट थोड़ा सा मैंने टेम्परेचर राइज किया, यहां पे मैंने टी प्लस डी टी कर दिया. ठीक है, ये उसी को समझाने का एक तरीका है. दिस इज अनदर वे ऑफ मेकिंग यू अंडरस्टैंड द अबव जनरल केस which I have assumed. Okay, let's start with these 2 points. Okay, and let this be process 1 to 3, and let this be process 1 to 2, I believe. Yeah, 1 to 2. Now for each of these 2 processes, okay, let this be process 1 to 2, and I make a second column in which we have process 1 to 3. Now let's start by writing ideal gas equations. PV equals to nRT. Okay, this is equals to already. And again in second also we write PV equals to nRT. Now differentiate both sides. Okay, we apply a change in both sides. That will be equals to PdV plus VdP is equals to nRDT. Okay, and in this case also PdV plus VdP is equals to nRDT. Okay, so end result is same. nRDT, rather it be process 1 to 2 or process 1 to 3, these terms are constant for both the processes, nRDT. What we are left with is that these two quantities, either in first case, PdP is gonna be more and VdP will be less, or it could be like VdP will be more, PdV will be less, but the net summation is gonna yield a constant value, that is nRDT. Now, let's think of why. This is P and this is a starting initial value V. So in which case, we are concerned with this part actually, PdV. That is only the work done for this, very infinite stimuli process, infinite stimuli process. Okay. So PdV is going to be more for, I believe, this 1 to 3. Why? PdV is nothing but dV is what? It's actually the projection of this line on the y-axis. Now, you'll have to understand for the process whose slope is less, the projection is gonna be more. अरे ये जितना इधर की तरफ झुकेगा ना, ये उतना ही इधर प्रोजेक्शन देगा एक्चुअली, ठीक है. और यही प्रोजेक्शन तो अपना काम का चीज़ है. VDP तो ठीक है यार, और VDP तो V कांस्टेंट है DP के केस में. अब देखो VDP में तुम देख लो, VDP किसका ज़्यादा होगा? VDP इसका ज़्यादा होगा, ठीक है. इसका कम होगा, क्यों? क्योंकि इसका जो प्रोजेक्शन है वो कम है कंपेरेटिवली टू द सेकेंड केस जिसमें VDP का प्रोजेक्शन ऐसा कुछ आएगा. तो VDP वाला जो है वो सेकेंड केस में बड़ा होगा, PDV छोटा हो जाएगा. बट वी आर ओनली कंसर्न विद दिस पार्ट, PDV कहाँ ज्यादा होगा? इन विच केस द PDV इज गोइंग टू बी मोर. सो PDV is going to be more for process 1 to 3. I hope this makes you clear. Now I'm concluding it again. Okay. We assume it to be a more general case, and we see that from process 1 to 3, this is tending more towards the isobaric side. Okay. And for process 1 to 2, this is tending more towards the isochoric side. Okay. We're not given a particular angle theta or something, so we can adjust slightly. Okay. And for isochoric processes, we see that the work done is tending towards 0 in most of the cases. Okay. I do understand that exactly this won't yield a 0 value of work, but comparatively, since this is tending to an isochoric process, this will eventually lead you to a very less work yield. Okay. But in comparative to 1 to 3, this is an isobaric process, and you see that graph bhi idhar ja rahi hai, so this projection is going to also increase, and that is actually the volume change. So clearly this is yielding more work done, and more work done means more heat supplied. I hope this makes it very clear. Thank you.